Hello, and for this tutorial we're going to teach you how to import sprite sheets, separate them up into individual sprites, and then create little small animations along with setting up the beginnings of a platformer. And away we go. Alright, with the Unity project open, the first thing I always like to do is create a bunch of folders to keep organized files. This way you won't have as much time rooting for folders, you'll know exactly where everything is. The main folders I like to create are animations, prefabs, scripts, and also textures. With that done, we'll now import all the new files of PNGs that are in the itch page. All right. With these files imported, you can then click and then shift click to select all, and you'll notice that we have all these different items here. One of the main things you need to look at for pixel art is your pixels per unit size, which is going off of 32. And since these are multiple, this is a sprite sheet, you're going to want to set sprite mode to multiple. And because of the way Unity works, they like to compress your files. So if you want really crisp pixel art, you're going to need to go to filter mode, set that to point, and then go on down to compression and set it to none. This way you'll have crisp pixel art lines, and you won't have any blurry effect. Starting off with the player model, we will go into the sprite editor. You'll get a picture of this. The main thing we want to look at here is automatic slicing. We'll switch the type to cells by grid by cell size because we know the size. And for our pixel size, we want 32 by 32. And then for the pivot, we want to set it to the bottom. And once you hit slice, you'll see the pivot is right here. It is the circle. That is where it will display the gizmos for moving around the player object. And that way we just have it on the base, on the bottom of the player for movements and stuff like that. Once you're done, hit apply, and then you'll have to go on to the outside here, and you only have to do this if the object is already in the world. You have to hit apply again on this area here. Now that we have that done, we can create our player character by hitting this little arrow button here. You'll see all of the sliced objects we have. If you click and then shift click to select all, and then we will drag that into the scene. And what this is doing is it's going to create an animation for us, pre-made. All we have to do is save it, and to do this we'll go back into Assets, go into Animation, and then we'll name this animation Walk. Hit Enter, and then if we go to our Animations folder, you'll see we have a Animator controller, and then the actual animation. And then if we click on our player in the world, you'll see that it already has the Animator sprite on there. One thing you want to do is to go into Windows, Animation, Animation, and this will bring up your window that you can drag anywhere on your screen here. We'll drag this to be right here. And you can see this is where our animation is. Once you can only see this when selecting the player character that has the animator on it. It will then show up here in the animation. If we play this, you can see that this is, in fact, it's looping around for our walk animation, so that's good. To make this easier, we need also a idle section, and to do that, with player character selected with the animator, you're going to want to click on the walk cycle here, create new clip. We will then call this one idle. We will set the samples to 12, but it doesn't really matter because it's just one. We're just going to be using this one sprite here. And this will be our idle sprite. And to make this even easier for the animator, instead of looping that one, you can then go into the animations folder, click on the idle animation, and where it says loop time, you can just turn that off. That way it will, once it's completed that animation, it will stop and it won't cause any little lag effects. Now with that done, we can now try to set this up to be better suited for when our player is actually animated. We need to go into Windows, Animation, Animator, and for the animation, you may not have it open, so the best way to go and open this is clicking on your player in the hierarchy, then double clicking the animator. Oh, it's already showed up. Nice. Now that you have this on screen, you can move this around, move these blocks around to organize them as best you want. The entry is what what animation will start on load-in of the game. So to change this, we're going to want to right-click on entry. Oh, sorry. To change this, we want to right-click on idle and set as default state. That way on entry, it will start in idle mode. And then what we want to do is then make a transition by right-clicking on idle and then clicking on walk. And now we want to right-click on walk and make a transition back to idle. That way we have these two states here where they can go back and forth between the two. And for a trigger to cause these actual items to go, you can create a conditional statement over here in the Layers tab. We can then click on this plus sign. Nope, sorry. We want to go to Parameters, click on the plus sign, and then we want to create a bool, and we want to name this bool is moving. With that created, we can now click on the arrow here, add a condition, and it will autofill to is moving true. And then we want to click on the other arrow going up from walk to idle, click conditions, and then set this is moving to false. That way, once we run a command to say is moving true, it will then go into the walk cycle. And then once that Boolean statement is not true, it will finish the walk cycle and then go back into idle. And that is the animation for our character. All right, with the animation set up, we should probably work on creating some form of ground for our player to walk on. To do that, we're going to go into our lesson tile set here. We're going to click on Sprite Editor, do Slice. Pixel size here is going to be 64 by 64. This one, we want the pivot to be in the center. And then we will slice that. You'll see we have our three positions here. We're going to apply, and then we're going to exit out of the sprite editor. Now for this, we're going to use a tile map, and also we're going to do something a little more advanced. We're going to use a rule tile set, which we can give into a set of rules to then use to create our edges so that it auto changes them to be whatever we want them to be. Now for this, we want to right click in the projects window here, go to create 2D tiles rule tile. We'll name this board tile set. And to access this, we now just have it in the inspector. Click on, if you don't have it selected, you can click on it. It'll show up in the inspector here. We're going to want to open up and see all of our sprites for the board. And we're going to click and click. And you'll notice that we lose our tile set on the inspector. To lock this, so we don't lose this, there is a lock button here. This will lock the inspector to stay on this component. We will now shift click to select all three, drag, and then drop into number of tile rules. This will give us three different options here. And what we want to do is so that there's two different options for how you can set this up. This is blank, so if there's nothing near it, it will place this one. You can see it here in our rule tile set here. It'll change based off our parameters. So what we want this to do, since this is the left edge, we want it to then say if there are other tiles, rule tiles of this kind to the right of us, we want to keep it there, and then also set this one to not have anything on its edge. So if there's nothing against this side of the left, or the left side of it, it will place this block. And now for the middle section, we want to only place it when there is a tile between both sides of it. And then we are going to mirror what we did for the left on the right side here by saying we only use this tile if there is something to the left and there is nothing to the right. Now with that set up, we should have our piece, our rule tile set. And to actually use this, we need to go into the hierarchy menu here, right click, 2D object, tile map, and we want the rectangular tile map. And this is set up to work on 16 by 16 pixels. So what we want to do in the grid is you want to, we still have to unlock it, you just need to click here, and now we can see our grid here. We want to have our grid selected. We want to change the cell size to 2, 2. Now in our tile map, we can't really just place the tiles using the rule tile set. We need to actually create a tile map thing. So to do that, we go into Window, 2D, Tile Palette. We want the Tile Palette window, and I'm just going to drag and drop this to be anchored right here. And you will see a Create New Palette in the drop down above, and that is in the No Palette. All right, you want to click on No Valid Palette, Create New Palette, and then it should give you this drop down. All we want to do here is change this, and we'll set this to Ground Palette. Everything else stays the same. You want to hit Create. It should give you this. This is where you're placing the actual tile map or tile palette. We'll just leave it here in the Textures folder. Once we have that, we should now have a tile palette to edit here. And now we can take our rule tile set, we can select it and just drag and drop into the tile map. It will create the grid automatically. And you'll see that we don't have anything here. To display something, if there's nothing, if it's only one of the rule tile, we need to actually set the default sprite, and we're going to set that one equal to the middle sprite here, and now we can see this. Alright, now we want to edit this and also place multiple others of that. To edit the sprite sheet, you need to click on this pencil icon here. It will allow you to edit things. We will do, if you don't have it already selected, you can hit I to get the eyedropper tool, then click on the square that you have it, and it should give you this now. We want to just do this so we can see that this is actually our board. And our tile map is not updating. Oh, there we go. Once leaving edit mode, we can now see that it is updated to the actual size of the tiles. Alright, now that we have the tile palette, we can now go into we can already see that it's already selected the first tile map in our scene. We can now use the brush tool to just brush in a area, and then press D to erase any mistakes that you have. And there we go. We now have a ground. We'll just create a little floor path here. Alright, with that created, we want to now actually add some physics to this game. And to do that, we're going to do, for the tile map, it has its own thing here. We want to add component. We'll type in tile map, and we use the tile map 2D collider. And you can see now it creates a bunch of small squares for each sprite. We want to reduce the load here and not have that many colliders in the game. We can do this by using the composite collider 2D, and it will spawn in a rigid body 2D. What we want to do for that, so it doesn't fly around, we want to just make this a static rigid body. That way it will stay in place and not move around. Now to actually use the composite collider, we need to go into the tile map collider and actually click used by composite. And now we have a giant rectangle for each area, which reduces the amount of colliders are in the game and increases performance. With that done, we don't want to just use only the ground tiles here. We also want to create some walls, and we have the book sprites to do that. Now, opening the sprite editor, we will now select the book area, which is a 32 by 64, I believe. Oh, I have that backwards, sorry. It is 64 on the X, 32 on the Y. We will now create and slice our area here. We now have our boxes. And what we want to do here is we want to be able to modify the size of these books. And to do that, we can go here and create a border of 12 on each side. It will bring out these green boxes. So whenever you're stretching the sprite, it will only take from the inside box and leave all these other portions the same size. That's a good way to preserve pixel ratios. We just need to do this for the rest. Alright, now that that's done, we hit apply, and we'll now have our items here. And to actually use that stretching behavior, we need to actually set the mesh type to full rect and hit apply. That way, once we spawn this in here, we'll just select one of these items. We'll select this one. We can see that it is this size, and we want to actually stretch it here. And the tool for that is the rect tool, which is T on your keyboard. Um, and you'll notice if we stretch it like this, it won't actually stretch properly. To actually have it stretch properly in the sprite renderer, well, you have to have it selected. In the sprite renderer, you change the draw mode to tiled. Now, once we stretch it here, you'll see that the pixel ratios stay the same. And to actually have a wall behave like a wall, we need to have a collider for it. So we need to add component, and we'll do box collider 2D. And you may notice that your box collider doesn't actually stay with the right size of your book. And to actually make it work with the tile mode system, you need to actually set the auto tiling checkbox on, and you'll now see that the box stretches with your book, and it will stay with the same size of your book. Alright, let's just populate this area with some items here. We can actually create a prefab, that way we don't have to set it up every time. We can do this by going to our prefabs folder, selecting the item in the menu here, drag and dropping this into the prefab, and we now have our prefab, which we can then drag back into the scene and create more copies of. This will allow us to change the original, and then it will affect all other counterparts in the scene. And we can also have it so that the scene has its own versions of it. So if we want to just change the look of this book here, we can then go into textures here, and we're just going to drag and drop this texture sprite into the sprite editor sprite, and we'll change the texture without affecting the others. The only time it will affect everything is if you're in the prefab itself. You can do this by going to the prefabs folder, double-clicking on the prefab to open the prefab menu. And let's just say we don't want the box collider on anymore. If we go back to the scene view here, you can now see that has affected all items. So it only affects all items if you are in the actual prefab menu. Alright, with our worlds created here, all we need to do now is go into the player and actually add some mechanics to our actual player. To do this first, let's give our player a box collider 2D, and then let's also give our player a rigid body 2D. And to set this up so that it works with the platformer I'm creating, we're going to increase the gravity scale to 2, and then we'll just leave everything else here the same. Now in our scripts folder, we want to create a new script, C# script, and we will name this player controller. To open this up, we are going to want to double click on the script and open up your scripting language platform. Mine is Visual Studio Code. And what we want to do here is, let's start off with creating some variables to control our player. Some of the first things we need to do is determine how fast we want our player to go. We can do this with a public float speed. Then we want the player to be able to jump, so we'll do a public float jump height. And then we want to be able to detect if the player is on the ground. To do that, we want a public bool grounded, which we'll use to determine if the player is grounded and can use a jump. And then to add some fun to this, we'll do a public bool can double jump. And that way we can give the player an extra jump while they're in the air. Alright, and now to control some of the components, we're going to need some, if we want to fire the animation, we need to actually call the animator here. And to do that, we're going to do a public Animator, and we'll call this Animator. Then we need to control the rigid body for jumps, so we need to do a public rigid body 2D, and the auto for this is just called RB for short. And we'll start off with that. If you don't want to drag and drop components in for the animation things, we can automatically set them on start here, which will be we can do this with anim manager equals to get component animator, and then the same for RB, we can do RB dot equals get component rigid body 2D, and this will set the components for animator manager to the components of our player. Now in the update, let's actually add some inputs from the player themselves. To do this, we'll do a vector2, we'll call this motion, and we'll set it equal to new vector2. And in the vector2x slot, we want input dot get access raw, and we will type in horizontal. This is using Unity's input system. It's a little old, but it's still pretty useful for creating a basic setup here. And then for the y-axis, we'll just set it to 0 for now. And what the get access raw is doing is it's looking for Unity inputs, and it will then give a value of either -1 or 1, depending on what direction the player is trying to go. So A is equal to -1 and D is equal to 1 on our inputs. And for actually getting those motions into the player, we need to do a transform dot translate, and then we want to use motion times speed times time.delta time. This way the motion will be applied in a more regularly speed, and it won't go off of the update, which is called every frame. So if you have more frames, you won't be going as fast because you have the time.delta time slowing it down to match a certain speed for each frame. Now let's add in the jump mechanics here. To do this, we want to do an if statement. So if, let's do is grounded, and then we want to check for an input dot get key down, and this will only be called if the key is pressed once. It won't be called multiple times. We then want to get the key code, and we're going to use space. Just have this autofill. So if we are grounded and the input from the player and they have pressed space, we will then run this code. And what we want to do here is, for platformers, I recommend setting the rb.velocity equal to vector2.0. This way it will zero out any velocity you currently have on the player. And then we want to then do rb.add force. We want to then use the jump height, and then because it's not as scaled as we want it to be, so off the start here we're just going to use times 500 to scale it properly. Oh, and also you need to actually determine the direction we're using here in the vector2, so we want to use vector2 dot up, because that's the direction we want to head, and that will create our jump. Now let's say we want to actually use our double jump in this same code here. We can then modify this if statement to use an or statement, and we will do if we're not grounded already and we still have our double jump and the input from the player get keyed down is space, key code space. We will then run our double jump as well in here. And to actually determine if the double jump, we want to actually make it so that the statements here are false, so we don't fly off the world here. So we will do if grounded, autofill this, and then we want to set grounded equals to false, else, because the only other option here is the double jump, we can do now double jump equals false. That way, once we have left the ground, it will turn off grounded bool, so we can't jump again. And then if we're doing this, calling this code, and it's the double jump, we can then set it so that the double jump is now false. Alright, and to actually make this work, we want to actually be able to make the grounded become true again. And to do this, we will use a new function here. We're going to drop down here, and we're going to do on collision enter 2D, and autofill that out. It will be private void on collision enter collision 2D collision, and then in here we want to do an if statement, if collision dot game object dot compare tag, and we will look for the string ground. We will then look in this if statement, and we will then set grounded equal to true, and also our can double jump equal to true. That way, once we've touched the ground, we will then get our ability to jump again and also our double jump again. We'll save this for now, and we'll head back into our view. We don't actually have the script on anything, so what we want to do here is select the player, drag and drop the script onto the player until you see this blue line. And we now have the player script here. Let's just set some values here. We'll set the speed to 4, jump height to 1. And you can, if you want to, set the animator and box collider, or the rigid body, already on here if you want, but it's already going to do that in our script, so we don't need to actually do that. We should now have a player controller that actually works here. Let's go into our scene view here, and let's start up the game real quick. We'll see our player falls to the ground, and we can move around with A and D. We can't jump though. Oh, you know what that is? The tile map here. So in our scene view, let's select our tile map in the hierarchy, and we want the tag. We don't actually have the grounded tag, so we wouldn't need to add a tag. We will do, list is empty, we'll need to do a plus sign here, new tag, and we're going to call this ground. And this is case sensitive, so make sure you have the same tag name as you do in the script. So all lowercase and then all lowercase, so this should work. Reclick the tile map and actually apply the tag ground. So now, back in our game view here, we can move around, and we can jump. And then we can do a double jump. Ooh, we can still fly. That's because we're touching the top here. But if we do this, you can see we have a double jump now. Alright, let's actually get our player animated to add some life here. Back in our script, after our jump menu here, we'll set up our animation now. And to do this, we're going to look to see if there is any motion, which is the player's input. So if motion.x is not equal to 0, we want the animation manager to set our bool that we set up earlier. And we want to call the bool, which is moving, comma, and we'll set it to true. And then else, if there is no input, we will set this animation manager dot set bool is moving to false. That way, once we stop moving, our player stops giving input, we will stop the animation. Save this. Let's head back into our scene here. You can see we're moving backwards here, but if we're going forwards, we do have the sprite playing. Now, if we want to fix this problem, we need to go back into our script here real quick. Let's do a check here. Let's do another if statement. If, let's see, motion.x is less than 0, which means we're moving backwards. We want to then get component sprite renderer, and then we want to do flip x equals true. And then if the input is the other way, we can do get sprite renderer and set flip.x equal to false to flip it back the right way. And we want to do this as an else is if motion is greater than 0. That way it will only flip once the direction, if the player input flips. So if you're standing still, it won't flip randomly. We'll save this, head back into the scene view here, play the game. Now when we move, we can see it will move in the direction that we're moving. Yippee. Alright, let's also make it so that the camera follows the player. To do this, we will select the main camera and we will drag and drop it to be a child of the character. So that way it's always following it, and we'll just position it a little bit above. Alright, now when we play the game, you can see our player moving, and the camera will move with us. Oh, and you might have saw there, we're tilting the wrong way. And this is caused by not constraining the rigid body. So we need to stop the game here. Let's click on the player, go down to our rigid body here. You'll see constraints. We need to freeze rotation on the z-axis. That way we won't have our player rotating, because we don't need it rotating. Alright, with that done, we now have a completely playable scene here with a player controller that does have a double jump and only works if we are grounded. You can see that there are some issues where you can scale the walls here because it is considering it a ground tile because you're colliding with it. There are some ways to fix this, obviously. It just requires a little bit more complex code, which we can get into the extra section, which is going to happen right now because we are completed. Alright, to start off this extra section here, we're going to give the player some dust clouds when they fall onto the ground. And to do this, we will be using our dust sprites here, open sprite editor. We're going to do slice, grid cell size. The X is 32 and the Y is 16. We will set the pivot to bottom, slice, and hit apply. Now we're going to want to create a prefab of this animation. So to do this, we need to click and then shift click to select all, and then drag and drop into our scene here. We want to save the animation here, so we'll go into our animations folder and we'll just call this dust cloud. And in the animations folder, we will set dust cloud to be loop time null, so it only plays once. Selecting our dust sprite here, we're going to name it dust. Okay, Unity's being weird. So we only want this to play once, and then we want it to delete itself. So in our scripts folder here, we're going to create a new script. We'll call this dust cloud, or just dust. And what we want it to do here is we want to actually get the animation animator. So to do that, we need to do animator, and we'll just call this anim manager. And then on start, we need to actually clarify what the animation manager is. So we'll do animation equals get component animator. And then in the update sequence here, we want to do an if statement, anim manager, and we want to see when the animation is actually done. And to do this, we need to do animation manager dot get component, or sorry, get current animation state info, do parentheses, set it to 0 because that's the layer we are on, and then we do dot normalize time, which is giving you the time in the animation. So once the animation is done, normalized time will equal 1. So what we want it to do is check to see if normalized time is greater than or equal to 1. And once that happens, that means the animation is done. So in the if statement, we want to call destroy game object, so that once it's done, it will destroy itself and remove itself from the scene. So it's not staying in some state where the animation is done. Save. Go back to our scene here. See if I can rename this. Nope. All right. Thank you, Unity. Click and drag dust onto our dust animation. And then what we want to do is in our prefabs folder, we want to drag and drop our dust sprite. So now we have a prefab of it. And to actually create a dust cloud for our player, we want to now click on our player, and then we're going to open up our player controller. In the top area here in our variables, we're going to create a new variable, public game object, and we'll call this dust prefab. And to actually create a dust prefab, we're going to want to do it so that anytime we fall, the player will create a dust cloud. So in our area here, we're going to do game object with a capital G. We'll call this temp equals to instantiate. And we want to instantiate our dust prefab. Then in the next line down, we want temp.transform.position equal to our player transform.position, and that is all we need to create a dust cloud. Back in the scene view here, we want to select our player, go to our player controller, open the prefabs menu, select and drag and drop our dust prefab into the dust prefabs position here for the player controller. We no longer need this prefab of the dust in the game, so I'm just going to delete it. And now, if we start the game, we should now have a little dust cloud spawning. And you could see that it is spawning behind the player. Now, if we want to fix this, we can actually we can select our prefab in the folder here, and we want to set the sprite renderer order in layer to 1. Now, if we continue playing the game here, you'll see that the dust cloud spawns in front of the player. We can see it better. This will just add a little bit more immersion to the game and just makes it look cool. Our second extra is here. Let's say we want the player to actually fall a little bit into the ground here so that when it's moving around, it looks like he's walking on the board. Now, to do this, we want to go into textures. When we want to open the sprite sheet for the board here. And in the sprite editor, there is this drop down to the top left. We want to select custom physics shape. We want to select one of our items here, and then we're just going to click and drag. You'll see a square form. This is what our physics object will look like. And it won't actually do it unless you are actually in the square, so it's a little bit annoying sometimes. There we go. You'll see these. This is our physics shape. You can select the squares to move them around. Let's drop this to about right here. And there we go. We now have our shape. This will create a physics object. Like for our box collider, this is what it will look like for our box collider. And if we want to just quickly copy this over, we can do copy and then paste and then paste. And then hit apply and close this. And then now to actually update our tile map, you'll see that it's not actually updating. The squares still go to the very top. To fix this, we can right click on the tile map collider here, hit reset, and you will now see that the colliders actually fix themselves. We need to actually reselect composite, and now it actually has the colliders that we want it to be. Playing in game here, you now see we fall onto the thing and just add a little bit more immersion to the game.